Imagine this. One morning, you wake up, look out your window, and the familiar golden orb is gone. Instead, something else hangs in the sky. A blinding giant. A silent, terrifying void. Or perhaps a pulsating beacon of death. What would Earth look like if we swapped our life-giving sun for a cosmic stranger? Stay with me until the very end, because the final scenario isn't just wild. It's a mind-bending twist that will leave you questioning everything. Our first replacement, a neutron star. Our sun is already a colossal furnace, but a neutron star takes that immense mass and crushes it into a sphere barely 20 kilometers wide. Imagine something smaller than a city, yet holding the unimaginable weight of 1,000,000 Earths. It's a cosmic relic, born from the violent death of a much larger star. Surprisingly, Earth would still orbit once a year, almost as if nothing had changed. The gravitational pull, despite the neutron star's minuscule size, would be eerily similar to our sun's. But the sky? Utterly dark. No daylight, no warmth, just an eternal, terrifying night. Within weeks, the consequences would be catastrophic. Our vast oceans, once teeming with life, would freeze into solid, impenetrable slabs of ice. The very air we breathe, our precious atmosphere, would collapse, condensing into rivers of liquid nitrogen. Crops would fail instantly, and our vibrant cities would vanish, entombed under an unforgiving glacial shroud. Humanity's only hope for survival would be to retreat into deep underground bunkers. We would cling to existence, warmed only by the residual heat from Earth's core, a desperate flicker against the encroaching cold. Look up, and you wouldn't see a sun, but a tiny, dim ember, the most terrifying silent dot in the entire universe. Would you survive in a frozen world, lit only by the ghostly whispers of X-rays and gamma rays? A world where the very fabric of reality feels stretched and alien? This isn't just a change. It's an extinction event, a slow, agonizing descent into cosmic oblivion. Now, let's swing to the opposite extreme. Imagine replacing our sun with Betelgeuse, a red giant star hundreds of times larger. This colossal star is so immense that if it were in our solar system, its outer layers would extend past the orbit of Jupiter. At first, the sight would be magnificent, almost divine. The sky would not show a distant disk anymore because Earth itself would already be inside the swollen body of Betelgeuse. What we would experience is not a horizon lit by a star, but a world submerged in a churning ocean of stellar plasma. That beauty would instantly collapse into horror. The outer layers of Betelgeuse would stretch past the orbits of Mercury, Venus, Earth, and Mars, swallowing them whole. Our planet would not simply burn, it would dissolve inside the star's extended atmosphere, reduced to little more than vaporized rock and molten metals adrift in a stellar sea. Farther out, the asteroid belt would vanish in a storm of ionized debris. Even Jupiter would not escape. Its vast atmosphere would be stripped into fiery streamers, its moons shredded into glowing trails of gas and dust. Bit by bit, the giant planet itself would be dragged into the expanding inferno until nothing of the inner solar system remained. Life, as we know it, would be utterly impossible here. To even contemplate survival, we would need to flee far beyond the orbit of Pluto, to the frigid, distant edges of the solar system. Only there, in the deepest cold, would the monstrous glow of Betelgeuse feel like a gentle, life-sustaining warmth. But red giants are not eternal. Their lives are fleeting, a cosmic blink of an eye. After a few million years, they either collapse into a white dwarf or, more dramatically, explode in a cataclysmic supernova. Humanity would be living under a ticking clock, a brief, fiery paradise that already knows its inevitable violent end. And if a red giant is bad, a blue giant is infinitely worse. Stars like Rigel or Deneb are hotter, brighter, and far more violent than their red counterparts. These stellar titans unleash energy millions of times more intense than our sun. They burn through their fuel at an astonishing rate, living fast and dying young. At 1 astronomical unit, Earth would be instantly scorched, vaporized in a flash of unimaginable heat. Our atmosphere would be stripped away in mere seconds, blasted into space by the sheer force of the stellar wind. The surface of our planet would burn to ash, leaving behind nothing but a molten, lifeless core. Even if we managed to flee outward, building cities on icy moons in the distant reaches of the system, the end would still be inevitable. The supernova that concludes a blue giant's life is an event of cosmic proportions. It would sterilize the entire solar system, flooding it with radiation so intense that no life could possibly endure. Imagine building a new civilization, finally adjusting to the blistering, relentless light of your new sun, only to watch helplessly as the star detonates, unleashing a wave of destruction that sweeps across the galaxy, erasing everything in its path. A paradise with an expiration date carved not in years but in the very stone of its existence. Would you take a few million years of glorious, blinding light, knowing that the bill for that glory arrives as an explosion that obliterates everything you hold dear? Now, let's consider the most common star in our galaxy, the humble red dwarf. These stars are small, cool, and dim, but they possess an incredible secret. They live for trillions of years. They are the universe's marathon runners, burning their fuel with incredible efficiency. If Earth remained in its current orbit around a red dwarf, our planet would freeze solid, a desolate ice ball in perpetual twilight. To stay alive, to maintain any semblance of warmth, we would need to drag Earth 50 times closer to its new diminutive star. This would place us in the habitable zone, a narrow band where liquid water could exist. But this proximity creates another profound problem: tidal locking. Just as our moon always shows us the same face, one side of Earth would forever face the red dwarf, becoming a scorching, arid desert, hotter than the Sahara. The other side would be locked in eternal night, a frozen wasteland as cold and unforgiving as Pluto. Only a narrow, perpetually twilight strip between these two extremes might remain habitable, a fragile ribbon of life. Even in this precarious twilight zone, survival would be incredibly fragile. Red dwarfs, despite their small size, are surprisingly violent. They are prone to unleashing solar flares 1,000 times stronger than anything our sun produces. These colossal bursts of radiation could blast away any nascent atmosphere, sterilizing the surface in an instant. Life might cling on in deep caves beneath the protective layers of oceans or within underground vaults. But imagine standing outside, one horizon always glowing a deep, fiery red, the other always shrouded in absolute, impenetrable blackness. No sunrise, no sunset, just an eternal, unchanging twilight. Could you adapt to a world with no day and no night, where the very rhythm of existence is fundamentally altered? A world where the sky is a static, unchanging canvas of red and black? Now, let's get darker, literally. Imagine replacing our sun with a black hole of the exact same mass. This isn't a supermassive monster, just a stellar mass black hole, the remnant of a collapsed star. The gravity would remain precisely the same. Earth would continue to orbit once a year, its cosmic dance undisturbed. The calendar wouldn't even notice the change. But daylight? It would disappear forever, swallowed by the invisible maw of the black hole. Within weeks, our vast oceans would lock into solid ice, their surfaces reflecting nothing but the distant stars. Within months, the very air itself would freeze, condensing into a thin, icy film. The surface of our planet would plunge to an unimaginable -200 degrees Celsius. Life, if it could persist at all, would survive only deep underground, feeding on the residual heat from Earth's core. Our vibrant, living planet would become a frozen, silent marble, orbiting an unseen, terrifying void. But let's not stop there. What if the sun was swapped with a supermassive black hole, millions or even billions of times heavier? This is where the true horror begins. Its immense gravity would stretch space itself, distorting reality around it. Earth would not simply orbit. It would be inexorably drawn inward, spiraling towards the event horizon, trapped near a glowing accretion disk of superheated plasma, hotter than any star. From Earth's surface, the sky would blaze with arcs of light and deadly X-rays, a terrifying, beautiful halo around the ultimate darkness. But this spectacle would be short-lived. The intense radiation would shred our atmosphere long before we could even begin to admire the view. This isn't just death, it's obliteration, a complete and utter erasure from existence. And yet, black holes possess a strange, terrifying beauty. A ring of fire around infinite darkness, a cosmic maw that devours light itself. Would you risk standing on a frozen, dying Earth just to witness such a profound, destructive marvel? From black holes, let's turn to another monster of the cosmos, pulsars. These are incredibly dense neutron stars, but with a terrifying twist. They spin hundreds of times per second. As they spin, they fire incredibly powerful beams of radiation like cosmic lighthouses sweeping across the universe. Imagine Earth orbiting nearby. Every time that intense beam sweeps across us, the atmosphere would flash, ignite, and burn, only to fade into the cold darkness as the beam passes. Miss the beam, and Earth still freezes into a lifeless ice ball. Catch the beam, and Earth is sterilized in seconds, its surface scoured clean by unimaginable energy. Living near a pulsar would be like living under a sniper scope, constantly waiting for the next shot, the next pulse of death. There would be no escape, no shelter from the relentless rhythmic destruction. It's a cosmic game of Russian roulette, with the entire planet as the bullet. Now let's go extreme in a completely different way. Not one star, not two, but three. Picture Earth orbiting in a triple star system, a complex ballet of gravitational forces. 3 suns blazing in the sky, each with its own unique color and intensity. Some days, all 3 suns would rise together, their combined light and heat overwhelming. Temperatures would soar, oceans would boil at the equator, and life would struggle to survive the intense radiation. Other times, Earth would drift into the shadow of one or more stars, plunging into an extended, bitter cold as if winter would never end. The very concept of seasons would cease to make sense. A year could last 2 months or perhaps 2 decades, depending on the intricate dance of the stars. The gravitational tug-of-war between these 3 celestial bodies would twist and distort Earth's orbit, eventually flinging our planet out into the cold, dark abyss of interstellar space. Imagine standing on a mountain, gazing up at a sky ablaze with 3 distinct suns, casting 3 shadows stretching in different directions. Beautiful, yes. A spectacle beyond human comprehension. But beneath that beauty lies an inherent, terrifying chaos, waiting to tear the world apart, to unravel the very fabric of its existence. Would you trade the stability of our single sun for the breathtaking, yet ultimately destructive spectacle of 3 suns? So, what have we learned from this journey through cosmic nightmares? Replace our sun with almost anything else, and Earth faces an unimaginable disaster. Red giants scorch it into a cinder. Blue stars explode, sterilizing everything. Red dwarfs freeze it, then blast it with deadly flares. Neutron stars and pulsars sterilize it with radiation. Black holes erase the sky entirely, plunging us into eternal darkness. Triple star systems tear orbits into chaotic oblivion. Our sun is not just special, it is perfectly balanced. It provides stable light, gentle warmth, and has sustained life for billions of years. It's a razor-thin balance, a cosmic miracle that makes Earth possible, a haven in a universe often hostile and unforgiving. We take its steady presence for granted, but its absence would be our undoing. But here's one more thought, a final, tantalizing question. What if we didn't replace the sun at all? What if we made a second sun? Jupiter, our solar system's gas giant, is massive, a failed star waiting in the dark. What would happen if it finally ignited, if it became a star in its own right? 2 suns, double shadows, a solar system transformed, forever changed. That's the story for our next video, a journey into a binary star system right here in our cosmic backyard. So, if you found this journey through cosmic possibilities as terrifying and fascinating as we did, please like this video, subscribe to our channel for more mind-bending science, and hit that notification bell so you don't miss what happens when Jupiter becomes a star. Join our community of cosmic explorers and let's unravel the universe's greatest mysteries together.